On vectors today. We're going to kind of avoid the really messy application problems till tomorrow. Does that sound okay? So we're going to start by breaking things down into components and drawing them correctly, deciding when something's a vector versus a scalar, and all kinds of good stuff. We're going to talk about magnitude and direction. So this is about kicking a football. It just says that you can draw a vector because when you kick the football, it's going to have both a magnitude, how fast it's traveling, plus a direction, right? Some kind of angle with the ground. Many physical quantities, such as speed, can be completely described by a single number called a scalar, okay? This indicates magnitude only. A vector has both magnitude and direction. So if we talk about the velocity of the ball only, that would be a scalar. But if we say at a such and such degree angle with the ground, then it's a vector. So real quick, a boat traveling 15 miles an hour, vector or scalar? Scalar, because there's no direction given in that problem, right? A hiker walking 25 paces due east. It is a vector. Paces are kind of an odd label, but it is some kind of a magnitude. A person's weight on a bathroom scale. That's a tricky one that we always think doesn't have a direction, but anytime you measure weight, it's a result of gravity down. So this is considered a vector, okay? And I wouldn't ask you that on a quiz. A car traveling 60 miles an hour, 15 degrees east of south. Vector or scalar? Vector. Parachute is falling straight down at 12.5 miles per hour. Vector. A child pulling a sled with a force of 40 newtons. Okay. It is only a scalar because it doesn't say a direction, right? Okay. Even if it just said forward, then we would know the force is in action. But okay. A vector can be represented geometrically by drawing what's called a directed line segment. It looks like a ray, but a lot of times they will draw it with a little, after the arrow, they'll also put a little line to show that's where it ends at the tip, okay? So it shows magnitude and direction. The initial point is called the tail. The terminal point where it ends is called the tip, all right? And it's written A, B, and sometimes they'll use this half arrow to show vector, okay? It's not a ray because it ends at the tip of the arrow. It does not keep going. If a vector has its initial position at the origin, we say its standard position, and the direction of the vector is a directed angle between the vector and the horizontal line used to represent the positive x-axis. So this one shown, the direction is 35 degrees. The magnitude is the length of the vector, and even though we could write a centimeter is 5 feet per second, the book actually assigns a bunch of problems. I'm not going to assign them, but where you have to draw things to scale, okay? So you have to figure out what you're going to use for your scale and then draw your vector to that scale. So if you're going to use a centimeter is 5 feet per second, and I want you to draw 20 feet per second, you would draw it 4 centimeters long. Does that make sense, guys? But we're not going to draw them to scale. We're just going to label them and move on. All right. So this is from the top of your notes. Says just exactly what we've gone over. And the direction we're going to talk about is between the positive x-axis and the vector. All right, eventually we're going to talk about, well, even today we're going to talk a little bit about quadrant bearings and true bearings. Okay. Quadrant bearings, it says, are between 90 and 0, east or west of the north-south line. So they're always measured off the north-south line. So this says, basically, starting at south, go 35 degrees towards the east. So it would be a 35-degree angle in here, which then we could name this as a negative, what would that be, guys, 55? You'll need a lot of geometry in this stuff, okay? A true bearing is a directional measurement always measured clockwise off of north. So if they wanted to measure off of north and end up here, this says 25 degrees. Okay, that's here. So for our purposes, we would call this 65 degrees in the positive direction off the positive x-axis. All right, we'll talk more about that later. And those notes about that are on the back of the sheet. We'll get there. But this question says, use a ruler, and we're not going to draw it accurately, but it says 20 feet per second in a bearing of 030. When it has this 0 in front, that's telling you it's a true bearing, so it's off of north. So we would draw this, and our theta here would be 60 degrees. I almost wrote 50. And then we would just label this as 20 feet per second. All right, I hope I don't have 10 examples of this. All right, just tell me you don't have, okay. What's the angle though? If this is given as 30 miles per hour on a bearing of off of south, 60 degrees towards the west. So I need a number off of the positive x-axis. You can go either direction. Which direction would you like to go? To get to this blue line, if I decided to go this way, what could I call that? Negative 150, okay? Or it would be positive 210, I think, if I went the other way. But I don't care which. It's just going to help us when we do the components in a minute if you get the sign right. All right. I'm sorry, the sign doesn't matter. It's going to help us with the components if we have the angle labeled correctly off the positive x-axis. The sign matters, but it will not change. It doesn't matter whether you went the positive or negative direction is what I'm trying to spit out badly. All right. The number 1 here says that 60 pounds of force at 125 degrees to the horizontal. So we could just say we're going this way. Theta is 125 degrees. And label this vector quantity as 60 pounds of force, and we're good. We're going to come back to this question in a minute and write the components, but for now, that's all they wanted us to do. Any questions? All right, where are we going to put this one? 55 miles an hour at a bearing of, yes, off of south towards the east. Now, does yours say 45? Because a couple of these I changed because 45 is kind of actually vague. They're telling us this is 45 degrees. If I asked you for an angle off the positive x-axis, what would you say? Yep, you could call this a negative 45 degrees, or you could call it 315 if you wanted to go all the way around. It would give you the same components in a minute. And the magnitude of our vector here, the length, is supposed to be 55 miles per hour. It's supposed to be an arrow, and I tried to show the little line at the end to show that it ends there. Again, we'll come back and do the components on that one in a minute. All right, number 3. What quadrant is this one going to be in? Off of north, 40 degrees to the west, right? So the angle they're giving us is off of north towards the west. We moved 40 degrees. I don't want that to be theta, though. What is my theta? Off the positive x all the way over to here is 130 degrees. Okay. And then I'm going to label this 30 meters in length. One more. 150 yards at 20 degrees to the horizon, horizontal. I'm just going to go this way, 20 degrees, and label it 150 yards. We good? All right. We aren't going to do much with these concepts, but just so you're aware of the vocabulary. Parallel vectors, okay, have the same or opposite direction, but not necessarily the same magnitude. So in this picture, everything except D looks parallel, right? All these A, B, C, E, and F. Some are moving in the equivalent vectors. In other words, they're the same length and the same magnitude or length and same direction. Like A and C look parallel and the same length, yes? Okay. C and E or A and E are called opposite vectors. They would totally undo each other. In other words, if I was pulling at a force of A here at this angle and you were pulling at E, that wouldn't move. Okay, they'd undo each other. It says basically if they're parallel in the same length, they call them equivalent. Okay. All right. And F is parallel to E, but it's twice the magnitude. Do you see the difference there between E and F? F is twice as long. Okay. We're not going to spend time worrying about drawing them very accurately, but we'll try to make them somewhat proportional. We do need to be able to find components, even if we're not going to worry about drawing them accurately. When you have two or more vectors and you want to add them together, you can find their components, which means the rectangular components, the X quantity and the Y quantity. So what amount of force or speed or whatever is acting in an X direction and what is acting in a Y direction. So if you're pulling a wagon here with an angle on the handle at a force of whatever, some of it's going in the X and some of it's going in the Y, okay, up and down. Those are the components. So here's a quick example. It says if you're pulling or pushing with 450 newtons at a 56-degree angle here. If we wanted the components of that, we can just find this X and Y quantity using what, guys? Yeah, right triangle trig, right? Okay. So they did cosine to find the X and sine to find the Y. Going back here, so cosine is adjacent over hypotenuse. We good? And sine is okay. Now, both of those are going to be positive. So it has this many newtons are in an X direction and this many of the newtons are in a Y direction. You have this example. Suppose Jamal pulls on the end of a rope tied to a dinghy with a force of 50 newtons at an angle of 60 degrees. And then it says, show the resultant X and Y magnitude and vertical components of the force. So again, as long as we label the angle off the positive x-axis, the cosine will always go with X and the sine will always go with Y. Okay, I can't stress that enough. If you draw the triangle differently, cosine could go with Y and sine could go with X. This is why we always use the bow tie angles, right? These guys. Because then our angle to the x-axis gives us the cosine here. This is going to be adjacent is this x distance, and sine will be the y distance. All right, so the definition we're going to use is that the length of the vector times the cosine will give us the x component, and the length of the vector times the sine will give us the y component. Okay, so we're just taking a leap ahead of doing straight right triangle trig, and we're skipping some of the steps. All right, now it says let's go back and do these for questions 1 through 4. So if we set this up like this, okay, and we used this angle in here, I'm not going to do it this way, but if we use that angle in here, I think I did that right. And the magnitude of the hypotenuse here is 60. So to find this x, we could do cosine of 55 equals adjacent over hypotenuse, and then the sine of 55 equals the y value here over the hypotenuse. There's a reason I'm not going to do it that way. These values are both going to be positive. Okay? Do I want x and y to be positive in this quadrant? Both of them? No. If I use this angle off the positive x-axis and I just do the magnitude times the cosine of the angle and the magnitude times the sine of the angle, I will get the same values, but which one should be negative? The x. All right, so let me prove that to you. What mode should I be in? Degrees, for sure. Okay, so on this blue over here, if I did 60 cosine 55, I would get 34.4. If I do the red for the same thing and do 60 cosine 125, I get negative 34.4. Same component, but this one is telling me it's pulling to the left. Okay, you can do it either way, but if you use the angle of the positive x-axis, it'll take care of the sign for you. You won't ever have to remember to change it to a negative. It'll do it for you. So we're going to have the components will be negative 34.4 and then 60 sine of 55 or sine of 125. What are we getting? Yeah, it should be the same thing either way, right? Because the y value up and down is the same. Okay, so I tried to do it both ways to show you, but if we use the angle off the positive x-axis, it'll take care of the sine for us. We'll never have to remember. Okay, so we're using this angle off the positive x-axis. We could use 315 or negative 45 will work. So what are we going to type to find the components? What is the magnitude or length? 55. And then cosine of, which one will give us the right sign? Off the positive x here, so we're going to use negative 45 degrees. And then 55 sine of negative 45 degrees. Now we could actually do that one with exact values because we know the sine and cosine are what? Yes. What are the values? Remember unit circle at all? Somebody does for a 45. Square root of 2 over 2 and square root of 2 over 2. Yes, but negative. So we could write this as negative 55 square root of 2 over 2 and negative 55 square root of 2 over 2. But if we're going to eventually do this as an application for something, that I'm going to want a decimal anyway, right? So if you did negative 55 times, I'm sorry, no, just 55 times the cosine of negative 45 got a negative 38.9. And then you did the same thing again with sine. You got the same value, right? Okay, the x was positive because it was going to the right, and the y was negative. What was it again? 30? Okay, thank you. That was my confusion. So it went to the right, but it's being pulled to the right and down. And right here, when I said this would have been negative, I lied, right? Because it's to the right. I messed that one up. Okay. So what do we want to use for number 3? .30 is the magnitude, and we're going to use the angle of 130. So that we should get what kind of an answer? The x should be negative and the y should be positive. Negative 19.3 and basically 23. Did someone else get those? All right, and can you do this last one then? 150 times the cosine of 20 and 150 times the sine of 20. Anybody got an answer for me? Someone else get those? Yeah. Anybody know what I could do in theory to check that? Yes. In theory, this is pulling over a force of 141 and up a force of 51.3, or a distance. So if we did Pythagorean theorem, it should come out about 150 there. Okay? Depending how we rounded. All right. So on the back, we're going to do some more, but they're going to do, they're going to give us some of these quadrant bearings and true bearings, okay? When they say something like this with 2 directions, it's either off of the north or south and then in the direction of. And if they give us a number that's 3 digits long with no direction and they say bearing of, then it's a true bearing, which means off of north clockwise. We are going to not do the icky ones today, like the airplane blowing the wind and blah, 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 blah. We'll do those tomorrow. But for today, if we were to draw a vector and find the vector's horizontal and vertical components, okay? So let's draw this in what quadrant? Just says from the horizontal, so let's just go around this way. 120, and it says to label it 7 inches. So what am I going to type for the components? 7 cosine 120 and 7 sine 120, which should be negative. Yep, going to the left, so I should get a negative x. Anybody get negative 3.5? And positive. Everybody good? All right, they get a little more complicated. This one is what? Off of north, 50 degrees towards the west. Oh, okay, thanks. I did change a bunch of things, and I thought I caught them all when I redid the smart slides, but not that one, apparently. All right, so let me erase this. Thank you for stopping me before I got too far. So it says off of north 50 degrees towards the east. So what do we want to use for our theta? Yeah, we want to use 40 degrees. So then this we can label 2.5 centimeters per hour. That's pretty slow. I don't know what's happening at 2.5 centimeters per hour, but maybe our blade of grass is growing in preparation for needing to mow the lawn, right? Yes. It said from the horizontal, so neither. It's giving us the direction, okay? Good question. All right, let's finish this one. Did anybody type 2.5 cosine of 40 for me and 2.5 sine of 40? These little arrowheads are just what they use to keep it separated. It kind of is an ordered pair, but they want you to know that we're talking about vectors. I got 1.92 if I decided to go two places all of a sudden. I don't know why. Something like that. And 1.61, you can just do 1.9 and 1.6. I don't care. It doesn't say. Okay. By breaking things down into components, then we're going to be able to add them. That's where we're going next. Number 4, a true bearing. This means off of north in what direction? Clockwise, okay? It's painful because it's not what we normally do. We don't measure off of north and we don't go that direction, okay? But that's how they measure for things like air traffic controllers, ships, measure off of due north, all kinds of stuff. True bearing, okay. What is our measure going to be? If we went around 140, we want to call this what? It is a 50-degree angle. Is that going to get us the right signs? Yeah, we need to call it a negative 50. Otherwise, we'll end up with two positives. And this is 4 centimeters. So if we do 4 cosine of negative 50 and 4 sine of negative 50, what do you have answers for me? 2.63 and then negative 3.1. Anybody agreeing with those? Thank you. Nadia is pulling a tarp along level ground with a force of 25 pounds directed along the tarp. If the tarp makes an angle of 50 degrees with the ground, so I'm just going to have her pulling off this way. Okay, the tarp is making a 50-degree angle with the ground, and this is the tarp. And she's pulling with 25 pounds of force along the tarp this way. Okay, find the horizontal and vertical components. Well, long as the angle we said is with the x-axis, right? Then we just need to do 25 cosine of 50 and 25 sine of 50. $16.1, anybody? $19.2? Okay. So that 25 pounds of force, or, yeah, it says force, could be broken down into two parts. How much of it's pulling horizontally and how much is pulling vertically. Everybody good? Okay, we're going to move on to adding vectors tomorrow, but if right now we're going to go to the easy stuff off worksheet 3. Okay, so we're going to talk about component form in the coordinate plane. Superzo and I kind of decided to stick with all the easy stuff today. And then tomorrow we'll get to the adding the vectors and the applications, and that way whatever time we have tomorrow, we can do as many of the applications together as we can get through. Does that make sense? All right, so when we put a vector in the coordinate plane and we start talking about from here to here giving ordered pairs, okay? So remember, there are many equivalent vectors. All of these are equivalent. Do you see what I'm talking about? They all go over 3 and up 2, okay? So all of these are equivalent vectors. Since vectors of the same magnitude and direction are equivalent, many vectors can be represented by the same coordinates. Okay? To find the component form of a vector that is not in standard position, you can use the coordinates of its initial and terminal points. So where does it start and where does it end? And what we're going to do is we're going to say how far did it go left and right and how far did it go up and down. So if this shouldn't be difficult if you have good number sense, but it can be very difficult for those of you who don't know your signed number stuff very well. This says it's going from A to B. That's what this notation means. Okay? So if I were to sketch this real fast, -4, 2, and 3, -5. This is A, this is B. It's going from A to B. All right? So if you were to say to yourself, it went from, the x coordinate went from -4 to +3, what happened? To the right 7, yes? And the 2 went to -5, which would be down 7. Okay? Now, what they say is that you can do the second, because this is where it wound up and this is where it started, you would do 3 minus -4 for the x's, and for the y's, you would do -5 minus 2. Okay? x2 minus x1, y2 minus y1. I don't usually do it that way. I just do it in my head, okay? Is it going up or down? Is it going left or right? But if you need a formula, there it is. All right. Then to find the magnitude, it's just how long the vector is. So if we know it goes from here to here, and we could use distance formula, but couldn't we also just use Pythagorean theorem if we broke it into components? All right, so that's what we're going to do. So on this question, if we wanted to find out how long this vector is from here to here, well, we could say if it went to the right 7 and down 7, then we could do Pythagorean theorem. Square root of 98, maybe? Or 7 square root of 2. Anybody know where I got that? Special right triangles, right? All right, let's talk about, let's talk about this one. All right, it says you have this vector or this ordered pair to this ordered pair, and it matters, guys, whether it's going from x to y or y to x. Those would be opposite vectors, the signs would change. It says it's going from x to y. So if I look at the x coordinates, 2 to -6, what happened? 2 to -4. Kind of gave that one away. That would be -6, right? -3 to +2, 5, okay? If you want to use the rule, you have to start at the end and subtract the first one. So -4 minus 2 is -6. 2 minus -3 becomes plus positive. All right, then to find the magnitude, we're going to do Pythagorean theorem. Always, 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 and forever, okay? When they want the magnitude of something, if we know the components, we're doing Pythagorean theorem. So if it's going left 6 and up 5, we just do Pythagorean theorem, and remember Pythagorean theorem is going to make it positive. So 36 and 25 is what, 61? Square root of 61, or, oh my goodness, I can't even do it when it's right in front of me. Square root of 61 or 7.81. Okay, that's the magnitude. How would we find the direction? Because eventually we're going to need direction. We're going to need an angle, so we're going to have to do like inverse tangent. Okay, let's do this with component and magnitude. Okay, so it says A to B. So if we're going from A to B, what happens here? Vector AB has components 12 to 52 went positive 40. You can do 52 minus 12 if you want. 41 to 33 went down, right? 33 minus 41, 8. Thank you. Those are the kind of subtraction problems I get wrong. All right, and then to do the magnitude, this is the symbol they will use for magnitude, guys. These double lines a lot of times, double absolute value looking things. So the magnitude of vector AB is going to be 40 squared plus -8 squared square rooted. Square root of 1664. Did anybody get that number? Oh my goodness, I cannot type today. Yes, I got 40.8 as well. That's fine, yeah. All right, couple more real quick practice. From -15 to 7 is what? Or 7 minus -15 should be 22. Are we good? And from 0 to -19 is just down 19, or -19 minus 0. So then if we do the magnitude, 22 squared, oh my goodness, I don't know where that 0 came from. Anybody get 29.1? All right, 2 to -1 is left 3, 4 to 3. Okay, if you need to, remember it's the second one minus the first one. Square root of 10, I'm guessing, yes? Which is 3 points. 3.16, 3.2, I don't care. Square root of 10, right? All right, one more section we're going to cover today. When you are given the components, okay, so it's already been broken down into components, then you can add, subtract, and multiply by a scalar. So if you knew you had a quantity that was going 3 to the right and up 5, and you were going to do that 3 times, okay, you could say it's going to go 12 to the right and up 15. It's the same thing, that scalar multiplication. All right, this is super easy. Please notice these are already in component form, right? That's what the little goofy parenthesis things are. So to add them, all you do is add the x coordinates and you add the y coordinates. So for b right here, it says take s and multiply it by 3, so make it 3 times as long and then add it to vector t. Well, all you do is multiply the x and y components of s by 3 and then add the components of y. So they showed some work here. They multiplied both of these by 3, then they wrote the components of vector t down, and then they added them together. So f minus g would be 4, -2 minus 24, 21, which would be what? -20 and -2 minus 21 back here. So -23. All right. G is 24, 21 minus 2 times f, which is 4, -2 plus 3 times h, which is -1, -3. Just to make my life a little easier, I'm going to do the multiplication first. So this one is twice as long. So it's 8, -4. I didn't distribute the negative, I just left the negative out there. And this one is 3 times as long. And then we're going back this and forward this. So 24 minus 8 would be 16, and -3 is 13. Did I do that right, anybody? Yes? No? And then 21 minus -4 would be 25. The plus minus 9 is 16. Okay, you want a whole bunch of those on the next quiz, right? Because those are super easy. Okay. Yeah, use your calculator, you'll be fine. All right, so you should be able to do all of the first assignment listed on the assignment sheet and actually part of the page 497 if you wanted to get started on that one. In the back of the room, there is a copy of the bookwork. One side has 8.1 book problems on it, the other side has 8.2, okay? So, and the homework check sheet. This is pretty easy so far, but some of you have never seen this or haven't seen it in a very long time unless you just had physics, okay? So do your homework.